Yes. Huh? You're like whispering. Gabrielle. Is that true, Gabrielle? Gabrielle. Connect. Did I say it right that time? Did you connect? I am? Oh. Yeah. I try to hear your voice before I say her name. TN. Christopher's not here. Oh, Jefferson's not here. Not official without a Jefferson. Darla. Okay. No. Page.
I love this baker. This baker. Sit down.
Oh my god, I finally got the page numbers right. Really? Yeah. Oh, you actually?
Oh, so never mind. Why one external? Don't say it. I mean,
oh, you're talking about that thing?
What do you have?
My dog is
Oh, what did I call it?
divided by external. Okay, yeah. So what's the difference?
Oh, I know.
It's a better because everybody What'd you get? Number 1. I didn't get that. What do you find? What do you find to look at the line? That with the same line.
Yeah, they changed it. Can you hear us talk? Yeah. Oh my God. Yes. Oh yeah, I have it.
That's what she is. Get the Wi-Fi. So you have that. You're taking the calculator and that.
Also, those are your. So these are your. So these are your boxes. So these are your X2. These are fixed.
Oh.
I was looking at the note card, but that's my system, so you have to take it. Yeah,
I know.
That will be making sure.
2 minutes, you got 2 minutes. I don't help. Your group helps. Alright, listen. Number 1 and number 3 are definitely easy. Number 2, you will never be able to answer number 2 unless you do something.
Wait.
I could be wrong.
Wait, what is backwards? Okay, so that's number easy.
Is it?
Yeah, you gotta do stuff on number 1.
You gotta do stuff number 1 and number 3, but number 2.
You said it backwards before.
If number 2 is that easy, then I am impressed with this class.
Wait.
Why? I mean, you could be that smart.
No.
We're gonna find out in a minute.
A double flow.
Okay. Still pick. That's impossible.
Yay. No, literally, you're like, hey, me out.
That's a line. Number 2 hard.
Number 3.
Dominic, where's Dominic?
And Y equals MX plus 9.
And then label your X, Y. Did I get it right? Okay. 1 and Y was the second one that we substitute the rest. Probably math.
Yes.
And then
Make sure you sign.
subtraction first. And then leave it as a fraction.
Alright. Let's start going over these. Hopefully, hopefully you guys all are that smart, and number 2 is that easy. I will just say that if it is that case, this is the first class out of 6 that is the case. But I want to believe you because I want to be impressed with my 6 period.
You just looked at mine.
Let's go over number 1. Gabrielle, what'd you get for number 1? Let's start there. I can't hear. What's that? And how did you get negative 1/3? So you use the slope formula? Be careful with the slope formula on this one. Number 1, you get a negative number on top, and people usually don't like to get negative numbers. And then on the bottom, you have minus a negative. Minus a negative gives you what? Positive. So 3 minus 7 is negative 4. Negative, or 6 minus a negative is plus 6, so you get 12. So negative 4/12 simplified is 1/3. Who graphed it? Anybody? There's always an algebraic way to solve things and a geometric way to solve things. You're in geometry, so you get to use it whenever you want. This is the algebraic way to solve things. This does not surprise me since you just got out of algebra, but you can always just graph it. When you graph it, to get from point A to point B, you're going to go down 4. That's your rise. As you're going down, that's negative. So there's your negative 4. You're going to go to the right. To the right is positive. You go positive 12. So there's your negative 4/12. No, it's wrong. If it didn't come out like that, that just means you didn't graph it right.
I just don't have the lines.
Alright, let's see who got number 2 right. Because number 2 is easy. Easy. Silas? I want to hear him clear. Wait. So, what do you call 2 parallel lines with the same Y-intercept? And you said you call that undefined. I'm going to say no. TM? I said right there. TM. TM, I said your name right, so you got to get my question right. TM, what do you call 2 parallel lines with the same Y-intercept? Huh?
I'm not sure.
Not sure means you have an answer. What's your answer?
I said that wouldn't be possible.
You said it wouldn't be possible? It's possible. They wrote it right there. Shh. Why can't it be possible? So I wrote something that's impossible on the board?
But no. Yes, and. Oh, you're actually going to pick on me?
I put they can't have the same y-intercepts because they would intersect, therefore making it not parallel.
But they are parallel. It says it right there, and they do have the same Y-intercepts. It says it right there.
But that's incorrect.
It's not incorrect when it's right there. Who else wants to try? No, there can't be 0 lines when it says 2. There's 2 lines there. Huh?
Is there a trigger on the question?
No. Wait. Yes. Hang on. There is a trick around this question. The trick is that you do exactly what they said. This is my question. I wanted to say it backwards. I said number 1 and number 3 were easy because they are. Number 2, you will not be able to answer unless you do something. You can think about it till you're blue in the face. You will never get it right because you're always going to go back to that mental, they're parallel with the same, that doesn't make, it makes complete sense. You have to do it. If you do something, you'll get this right. Who wants to try?
But isn't it just like one line?
What are you saying?
Okay,
What I'm saying is that would they have to be on the same plane?
Divorced parents.
They're parallel lines. Parallel lines have to be on the same plane.
Okay.
Would it just be one line?
What?
Wait, I got it? Would it just be one line?
Did we know?
One line, yo. The same line.
That was wrong. Let me go out to look. What are you talking
Alright, here goes. I am going to show you how to do this algebraically. And this is not hard. This is a very easy question. You guys have to get out of that mindset. You're thinking inside the box. You're inside of a tiny little box like this. Parallel lines only work this way. Only Y-intercepts that way. That's the only way in the entire world on Earth that it'll ever happen. It will never happen any other way. There you go. No. None of this stuff is etched in stone. There's always an abstract way of thinking. This is abstract. What is going on here? What's going on is the fact that they told me that I have two parallel lines. This is the equation of a line, correct? Okay. How do I know if two lines are parallel based off of this guy? Not the y. Parallel lines have equal. What part of that equation? Slope. Slope. Did they tell me what the slopes were? No. Awesome. That means I'm going to do this. Are those two lines parallel? Yeah. They have the same slope. Continue on with the sentence. With the same y-intercept. What can you tell me about those two lines?
They're the same.
Same line. Done. That's crazy. Do exactly what they said. And then see what happens. I am going to challenge your way of thinking all year long. Hopefully, my goal is the harder you think the question is, the easier it actually is. What about the last one? Elizabeth. Where's Elizabeth? Elizabeth? What did you get for your final one? What's your answer? You didn't solve it? So how would you find your answer? What would you have to do to find your answer? In y equals mx plus b, what one of these components is your slope? The m. So what do you have to find? It says what is the slope? So you need your m. But you need this to be in that form. Is it in that form? What am I doing to that equation to get it in that form?
You're subtracting the 3x from both sides.
I want to solve everything for y. Find the one letter that you're trying to solve for. That is the one letter you are not going to touch. This equation says y equals. That means this equation has to say y equals. Since it says y equals, the y, I'm guaranteed I am not going to move that letter. It's going to stay right there. I'm going to move everything else around it. So your first step, subtract 3x. Are these like terms?
No.
So I can combine them, right?
No.
That was a trick question.
Do you divide by 2 on all of them?
Divide by 2, and I'm done right there. I don't have to finish.
Well, you don't have to divide by 2 on the 6.
What does the 6 represent? Is that my slope?
No.
Then who cares? I don't care what the 6 does. They said the slope. They asked for the slope. Is this your slope? Will this simplify? No, so you're done. -3/2. Your slope.
So say on like geometry, you'll see, we wouldn't have to like divide by 12.
You have to answer their question. What was their question?
The slope.
Then you're done. Who cares about the rest?
Is it like?
Can I finish and solve the whole thing and get a nice pretty equation all written down nice and neat?
Yeah.
Yes. Will my answer be marked wrong either way? No. So I'm all about shortcuts, guys. I told you the first day of school I don't like to work. You're going to give me a question, I'm going to answer it, and that's as far as I'm going. Okay? A lot of the questions on your EOC, you can do half of the problem and get the answer right. Because they're only asking for the halfway point. They're not asking for all the way to the end. You guys just choose to go all the way to the end. That's where it comes to really understand what you're doing, what you're looking at, and what you're trying to find. Okay? Alright. Get the worksheet out that we had last time that we just talked about the front. We didn't do anything with it. I am finding, actually I'm not finding, I found. There's no more question about it. I found out that one of your guys' weak points is graphing.
Yes.
I'm hoping my 6th period will shock me. You guys are the shock and awe class. That's your job every day. When we just talked about this last class, we were determining whether the lines were parallel, perpendicular, or neither. Parallel lines have equal slopes. The slope is your m when it's set up in y equals mx plus b form. This entire worksheet, all of the problems are y equals mx plus b. So there's a positive right there. You don't have to solve for y on any of them. That means your slopes are given to you clearly on every single problem. For this first one, the slope of my first line is 3. The slope of my second line is 3. Does 3 equal 3? Then the lines are parallel. Now when you're graphing, this is the part that seems like a lot of people struggle with. When you're graphing, you can only graph one line at a time. So don't try to graph more than one line at a time. It won't work. When you graph, always go to your B. That second number, your B is an actual point on the graph. So for my first line, I'm going to go to -1 on the y-axis, and I'm going to put a dot. Then you use your slope. Your slope is a positive 3, which is 3 over 1. Positive slopes are up and to the right. Negative slopes are up and to the left. So from this point, I'm going to go up 3 and to the right 1. There's another dot. Put a dot right there. Now you do not have to do this, but I like to go 1 in each direction. So if I'm going up and to the right, then I'm also going to go down and to the left. You need 3 dots to draw a graph. There's your 3 dots, draw your line. You do not have to do that. You can go up and to the right twice and get your 3 dots. Either way, you are going to be correct. You can put more than 3 dots if the graph is big enough and allows you, but you should not have any less than 3 dots. So for the second one, my y-intercept is -4, so I'm going to start at -4. The slope is the same. Up 3 to the right 1. Up 3 to the right 1. This one I can't go the opposite direction because the graph didn't go that low. So I'm going to go from that second point, and I'm going to go up another 3 and to the right 1. Here's your 3 dots, draw your line. Number 2 is different because it says y equals and x equals. Whenever you see y equals a number, that is a horizontal line. you're going to draw a horizontal line on that number on that axis. So on the y-axis at -3, I'm drawing a horizontal line. X equals is vertical. Same rules apply. I'm going to that number on that axis, and I'm going to draw a vertical line. So a vertical line at x equals -3. Y equals a number, horizontal, every single time. X equals a number, vertical, every single time. Y equals something x, that's always going to be a slanted line. For number 3, your slopes. Your first slope is -2/5. Your second slope is +5/2. One's positive, one's negative. If you take your first fraction and flip it, will you get your second one? That means that the two lines are perpendicular. Both statements must be true. One's positive and one's negative. If you take your first fraction and flip it, you will get your second one. If both statements are true, the lines are perpendicular. And again, my first equation has a -1 for its b, so I'm going to go to -1 on the y-axis, and then do the slope. This slope is -2/5. Negative is up and to the left. So I'm going to go up 2 and over 5. And then the opposite direction, down 2 and over 5. There's your 3 dots, draw your line. The second equation doesn't have a y-intercept. What does that mean? Where's 0?
In the middle, the origin.
At the origin. So that means if there's no y-intercept, your graph is going through the origin. But again, you're still following your slope. This slope is positive, so it's up and to the right. So you're going to go up 5, to the right 2. Down 5, to the left 2. There's your 3 dots, draw your line. I'm going to give you 3 minutes. I want you to graph number 4. Alright. We have some work to do. It's okay. It's okay. Your slopes. Your slopes are the easy part. One's -2, one's -1/2. Are those lines parallel, perpendicular, or neither? Neither. Are they equal? No, so they're not parallel. Are they opposite reciprocals? No, they're not opposite signs. Are they reciprocals? Yes, they're reciprocals. Reciprocal means the fraction has been flipped. Has this fraction been flipped?
Yes.
Yes, but are they opposite signs? No, they have to be both. Since they're not both, they're neither. Now, graphing. When you graph this, do either one of them have a y-intercept? No. So both of them go through the origin. From the origin, on your first graph, the slope is -2. Negative is up and to the left. So you're going to go up 2 to the left 1. Then the opposite direction, down 2 to the right 1. There's your 3 dots, draw your lines. The second graph is a -1/2. Negative again is up and to the left. So you're going to go up 1 to the left 2. Down 1 to the right 2. There's your 3 lines. Draw your graph. Now here's my question. Raise your hand high if you got that right. Okay. So we're starting off with 5. You know what close gets you? Nothing. Close gets you a wrong answer. You earn points in horseshoes and hand grenades for being close. This is neither. Alright, I'm going to give you another 3 minutes to do number 5 because we can't leave this with 5 people getting it right and the rest of the class not. Do number 5. You guys do know you can talk about it, right?
Oh, tiny.
Why would I put you in groups? Is this the one that's right?
Kind of.
Is that kind of?
Yes.
I'll never have it again.
That's parallel.
Draw the line. Might want to look quicker, but
What is it? 1/3?
Okay, so you're starting to negative 1 and negative 2, correct?
yes.
What's negative?
Because it's positive. It's only to the left side when it's negative.
You're looking at positive and negative.
But I don't know though. I'm not 100%. So.
The negative 1 is trying to put a dot right there. We're done with the negative 1. It's almost everything. So what if you do it?
It's just a negative 3, so it'll be the second one? Yeah. Yeah, so it's like negative 3, so it'll be up to.
That's your slope. That's what you're counting up. That's not 3. That's 3 on
Plus 2. This is for number 1. Plus this is for 1. Like all 1.
Samantha, what's the slopes of these two lines? Okay, go ahead, Kim. 3 and 2. Are those parallel, perpendiculars, or neither? Neither. Perfect. Now, for the first equation, right there, that one.
Yes.
Dora. Dora?
Yes.
Where am I going to put the first dot for the first equation?
Negative 1.
On
The y-axis.
perfect. There's two negative ones. There's one y, one x. Daniel?
Oh my god.
Daniel, my first dot for the first equation is at negative 1. How do I find my second dot? So what am I going to do exactly? Okay, how am I going to use it? Up and over what direction? Up and to the right? Perfect. Perfect. And if you can do that, up and to the right, then you can go down and to the left and get your second dot, or go up and to the right again to get your third dot. Janelle? The second equation. Where's my first dot going for the second equation? Negative 3 where? On the y-axis. Amber? How am I going to get my second dot from negative 3 on the y-axis? How do I get my second dot? I'm right here on this equation.
Okay.
Shh, I can't hear. Right, I'm already there. So where do I go from there?
Well, you rise up 2 and then run 1.
Which way is your run? Right? Perfect. Raise your hand if your graph matches my graph. Yeah, that's a lot more than 5. But that's still not enough. Nobody in your group got that one? Keep your hands up. Alright, that's still not enough. We need more, so do the next one. Number 6.
Wait,
Make sure you sign out.
Come on. Can you see if these are right?
I don't know. I'll tell you in 3 minutes when we go over number 6. So I'll tell you in 3 minutes when we go over number 6.
Well, no. When that's
Somebody else wants to help me with the time.
when that is negative, you go up to the left or down to the right. And when it's positive, go up, right, down, left. You will go up, yes. You will go up to the right, down to the left. Which makes sense for number 6. Because look, you put your point at -4, right? You can't go up anymore. So you have to go down to the left.
Is that right?
Down to.
It matches this.
Should be here. Right.
I'm going to go down to.
Can the whole class get this one right?
Yes.
Yes.
Yeah, I think.
Do we get a prize? Okay, so basically, if it's negative, if it's negative, you're going to go up to the left. Yeah.
Not this.
Just remember, no, that's not that close. It's so if it's negative, you have to do like this. No, it's not. And it started.
Down. Either up to the left or down to the left.
Yeah. Sorry.
That was confusing me. All of these are negative. It starts with this line.
I can't tell you.
Well, someone told me that if algebra was hard for you, that geometry is going to be easy if
Alright, number 6. Dominic, where's Dominic? Dominic, what are the slopes for the two lines? Alright, Dominic, is that parallel, perpendicular, or neither? Parallel, good. Page. Page. All I'm doing is looking at this one, the top one. What is the first point that I'm going to plot? Where? Done. So all of that extra business when I called your name was unnecessary. My questions are always very easy. Manal's not here?
No.
he's right there.
Where's Manal? Manal. For some reason I thought you sat there. Alright, Manal. I'm here. I plotted my point at 4 on the y-axis. How do I find my next dot? What is my rise over run? Yes. So, am I going up or down? So you want to rise up or down? Up. So if I rise up, then am I going to run left or right? Good. Good. Up 2 to the right 1. Or down 2 to the left 1. Sydney? Where's Sydney? Sydney. Sydney. I'm on the second one now. Where am I going to start? What's the first point you plot? On the... Perfect. From there, to get to my second dot, Layla, how do I get to my second dot? I'm on -3 on the y-axis using this equation. Which way's over? Right. Good. Perfect. So your graph should look like that. Raise your hand if your graph looks like that.
Oh yeah.
Alright, number 7, 3 minutes, go. Let's get the whole class together this one. This group over here is super excited for that. It just looks different, but it's the same picture.
And then our teacher was like, if you had to escape, you'd be alive, right? So one student has to go out, make sure it's safe for the rest of us to go out. And that's why the rest of us are telling you.
What are you talking about?
My first class, man. We're not my dumb people. I'm sorry, but
Number 7. Parallel, perpendicular, or neither. Who got it?
Wait.
Alright, do number 8. The whole class still get it.
it's showing. So that should be easy.
Wow. I already got that part.
I would rather have that bad than me be alive here with no protection going out to make sure you guys stay alive.
Go ahead.
She said, like, pretend the problem was happening over like near the senior meeting. Yeah, to go to the corner to see. Like, I don't care. Like,
It's a game.
I'm sorry. We were like, gonna die. You know you are gonna die. You come
Alright, look up here. I think I might have found one of the problems, probably one of the many problems that we're having in this class. When it comes to graphing. That's the dot to start this one. This one was on number 8. So it's y equals negative 1/3 x plus 5. Now, is the negative with the 1/3, is the negative with the 1, is the negative with the 3, is the negative with the 1 and the 3? Well, the negative can't be with the 1 and the 3 because what's a negative divided by a negative?
A positive.
Positive, which means that wouldn't be negative. So, the negative, it can be with the 1 or it can be with the 3. Here goes. If you do this, the way I'm going to show you, you can't get it wrong. You can't. So, slope is rise over run, correct?
Yes.
If you're going up, is that positive or negative?
Positive.
What about down?
Negative.
To the left?
Negative.
To the right?
Positive.
So, depending on what fraction you have, this or this, doesn't matter. Both of these are the same as that. We're good?
Yeah.
You're right here. If I choose for the top to be negative, that means I'm going down 1. Which means I then have to have the bottom positive, so I go to the right 3. If I choose for my top to be positive, that means my bottom has to be negative. So positive for the top is up 1, negative would be to the left 3. There's your 3 dots, draw your line. Your fraction, you're allowed to make either one, the numerator or the denominator, negative. If that one's negative, then you go that negative direction on the graph. If it's negative in the numerator, it's down. If it's negative in the denominator, it's to the left. Which means the other one has to be the positive direction. This one is telling you to go down and to the right. This one's telling you to go up and to the left. You can do that with every single slope, even if they're positive. Okay? Everybody better on this one because I left the graphs on the screen.
Yeah.
So if you raise your hand if your graph matches mine.
Wow, that's crazy.
Left them on the screen, guys. Alright. Alright, listen. This next part, for the rest of class, you are not writing anything. We are going over parallel lines cut by a transversal. I'm going to give you a total of 6 different angles, what they are, where they are, and what they do. You're not going to write a thing. I have your notes already written, but I'm not going to give them to you until we're done. I'm going to show you that these 6 angles, what they are, where they are, and what they do, you already know. Or can easily figure out. I'm going to prove you wrong. You see this over here? Over here on this window, you'll see for the rest of the year the standard and what we're working on. This is the standard. You have no idea what that means. That's fine. This is what the standard means. This is a short piece. This standard is actually written. It would probably cover all 4 of these windows. It's very wordy. But for the most part, we're proving theorems about lines and angles. We just prove things about lines. You can prove to me if lines are parallel or perpendicular by their slopes. Now we're going to prove things about angles. There's going to be a total of 6. Okay? We're good so far? Alright. So, to start, we're going to do this in complete and utter silence for 30 seconds. I want you to look at this picture and study this picture for 30 seconds. For 30 seconds, I want you to determine everything you know and can guarantee, because that's what proving is all about. You got to be able to guarantee whatever you can to me. So look at that picture and decide, pick out everything you know is true, all properties, anything that you can guarantee to be in that picture. Just think about it. Go. And again, you're not writing anything down. Just start thinking about it. Alright. That was 30 seconds. Now, we're going to do a round robin, starting with the person that corresponds in your group to this desk. You guys are just going back and forth. But everybody who corresponds to this desk in each group is going to go first. You have a minute. All you're going to do is say one thing that you thought of and then pass it on. We're going around clockwise. Once you get back to the beginning, you keep going.
What if we run out?
One round, go.
You can't think of it.
Good thing I didn't ask you. Alright. Where is Christopher? He's not here? Where? Who's Christopher? No Christopher. What about Damien? Oh,
What would you say?
Alright, all you gotta do is tell me something. What is true about this picture?
Capable.
I can't hear him. What did you say?
Line segment.
Line segment what? Every D is an angle, not a line.
Oh,
AB. AB is a line segment. Good. Andrea.
ABD is what you say.
Okay. Good. I'll take that. Alexis. Good. George.
Both A, B, D, and C, B, D make up 180.
A, B, D, C, B, D make up 180. I really like that. Can we expand upon that? What do we call that? Huh? What'd you say? Not mumbling it, just say it. Supplementary. There's supplementary angles. That's what I was trying to get to right there. ABD and CBD are supplementary angles. Here goes. If two angles share a side, you see how ABD and CBD share a side? That side is called ray BD. They share BD. If two angles share a side, they're known as adjacent. If you have two angles that are adjacent and supplementary, we call that a linear pair. Linear means line, pair means two. So we have two angles that form a straight line. You see that up there? Linear pair. You're going to see that word a lot in this classroom. Okay? We're good so far? Now look at this picture. Definitely not the same thing. Daisy? Yes. Daisy, what can you tell me about that picture? They have angles. Good job, Daisy. I'm very impressed. Ariana? Tell me something about that picture. No, we can't say that. We can't say that. Cheyenne? Of course. Lucky. Rodney? Tell me something about that picture, Rodney. ABD what? What did you say? EBD is vertical? No. No. It's neither one of those. Cameron? Who's Cameron? Cameron? AB is it's a line segment, good. Switch your letters. BA is a ray. Gabriella. You can't tell me more than those letters? I'm looking for something specific. Darla, where's Darla? Darla? Perfect. ABE and ABD are also a linear pair. They're also supplementary. They also add to 180 degrees. I'm so glad you said that because I wrote down exactly what you were going to say, or I was going to wait until you said it, which is angle ABD plus angle DBC equals 180. Angle ABD plus angle EBA equals 180. Study this picture, study those equations, and tell me something else. Raise your hand when you got it. Let's see who's brave. Who's brave? Your hand was first, right?
Angle ABD and A plus.
Wait. ABD, go ahead.
Angle DBC and they're all like, if you were like to add up all the angles there, it would be 260.
Correct. Everything is inside of a circle. You'll find out this year that everything in life is inside of a circle.
Angle ABD and angle EBC are equal.
How do you know?
Because we're all circles and both of them. I can't explain this really well. I know, that's how I do it. Explain it really well.
Yes, but you chose the wrong one. No.
Both lines.
No.
Isn't it because both lines cross a point on the plane? Or not the plane, but like...
No. B is the vertex. Watch. You're right. Wrong angle. Because you can't prove it using the angles you said. You ready? This angle, ABD, I don't know how to label this. Alright. I'm going to circle ABD in red, okay? ABD is right here. DBC is going to be green. And I'll do this one in blue. EBA is going to be blue. We're good? This is why you couldn't bring this angle in, because we don't have this angle. You're only allowed to use what you have. This says that ABD plus DBC equals 180. ABD plus EBA equals 180. They both equal 180, don't they?
Yeah.
So doesn't that mean that I can rewrite this to say that angle ABD plus angle DBC equals angle ABD plus angle EBA? All I did was set them equal. If they both equal 180, don't they both equal each other?
Yes.
That's all I wrote. Do you start to understand why I said you got to be able to read and name these things? This is what we're doing. We are now adding, subtracting, multiplying, and dividing shapes. You are going to have to be able to read these. This is why notation, this is why day one with the definitions was so important. Now look at these two. This is an equation. There's an equal sign. There's an equation. That means I can solve for something. That means you can do something. If you're allowed to add, subtract, multiply, and divide numbers, you can do the same thing as shapes. Now obviously I'm not going to multiply or divide because I'm not multiplying or dividing anything up there. But on both sides of the equation, I have the same thing, ABD. So what happens if I subtract angle ABD from both sides? You're left with angle DBC equals angle EBA. You're left with this angle is equal to that angle. Now you have just proven, it because this right here proves it. Nobody can ask you any questions on that. Nobody can dispute that. You didn't do anything mathematically incorrect. Are we allowed to subtract from both sides?
Yes.
Of course we are. It's a subtraction property of equality. It's a mathematical rule. I did it correctly, and since this came out as the answer, that means it is correct, and nobody can dispute it. So in the standard, we have just proven that these two angles are congruent. We have proven it without any numbers. How many people does that bother? That's going to bother a lot of y'all. Proofs are without numbers. It's abstract. If you can prove something without numbers, you have then proven it for any number that you can plug in there. Every single time you see this picture, which is just an X, everybody agree that's just an X, two lines that intersect. Every single time you see two lines intersecting, you can guarantee, because of this proof, that the opposite angles are congruent. Every single time, which is actually one of these angles, right here. Those angles are vertical. Vertical angles are congruent. We just proved it. Every single time. Good? So right now we have a linear pair. Linear pair, they're supplementary. Linear pair will form a straight line. And now we have vertical angles. Vertical angles are equal. They're congruent every single time. Good? I don't care what the picture looks like. If you have two lines intersecting, you have vertical angles. Guaranteed. Now we're going here.
Yeah, that's what I remember learning.
Alright. Corresponding angles is a postulate. We don't prove postulates, they're proven for us. So corresponding angles, when I said everybody corresponding, which is why I chose my words wisely, to this desk, how'd you know who was going first in your group?
Because it's the same on every desk.
Alright, you're pretty much all right. It's in the same spot. It's everybody who's sitting in the same spot in each group, right? So corresponding angles, corresponding to angle 1 would be what?
4, 5, and 8.
Corresponding to angle 1 would be what?
4.
5 and 8. 4, 5, and 8.
Yeah.
How is 4 in the same spot as 1? We just talked about 1 and 4. 1 and 4 are what kind of angles?
Vertical.
They're vertical.
So it would be 1 and 5.
Vertical angles happen at the intersection of two straight lines. Everywhere you see two lines intersecting, you're guaranteed to have a linear pair and vertical angles. 1, 2, 3, and 4 are either a linear pair or vertical angles. That's it. Corresponding. When I said corresponding to this depth, you guys didn't jump right here, did you? No. You jumped to one person in each group. These are all different groups. So what corresponds to y down here? 5. Now once you get down here, you would then have a whole bunch of linear pairs and vertical angles all over again. Correct?
Yes.
Alright, so I'm going to give you 2 minutes in your group to tell me what every single angle up here is. 1 through 8. Ready, set, go.
You will make up 60. Or it's going to be 120. Got it. I remember doing this last year. We did this last year. Yeah, all the pieces. Just mix and match.
Each angle is, right? Like 6.
You're going to tell me how much you measure that.
I'm sorry. I know.
I would think we got it.
We're about to find out. Got it?
Oh, put everything in my mind.
Do you know what it's just 2 numbers?
Okay, there. I could put more lead in it, but I don't know.
I know
Yeah.
Alright. Let's start with Gabriella. Gabriella is? Gabriella, angle 2 is how big? How do you know?
We did. Do I just answer?
Go ahead.
We did 180 minus 120 because the whole.
Why?
Because the whole line equals 180.
How do you know?
Because. This is great. Because it's a supplementary. No. I don't know.
No, it starts with an L. It starts with an L.
Linear.
Linear.
Pair.
Good job. Awesome. This is 60 because you subtracted it from this from 180. You were able to subtract this from 180 because they add to equal 180. They add to equal 180 because they're a linear pair. Everything stems from the fact that they're a linear pair. Listen, once you've proven a measurement, so now we've got number 2, and we just proved it. There is no more just giving me answers, guys. That's algebra 1. That's Miss Baker. You saw Miss Baker. She's gone. There is no more just giving me answers. Now you've got to prove your answer to me.
What?
Once you prove it, now we've proven 2 is 60 degrees. You've proven it. Once you prove it, you can then use it. So right now we have angle 1 and angle 2 to help us to prove any other question or any other number. So where's Alexis? Alexis, number 3. How big is number 3?
60.
How do you know? So how do they relate? Starts with a B.
It's not the
It's on the wall. Vertical. 2 and 3 are vertical angles. And again, because we already had 2 proven, we're allowed to use it. Could you prove it another way? Yes, you can use 1. 3 is 60 because 3 and 1 are a linear pair, and since 1 is 120, that means 3 has to be 60. Either way, it does not matter. There's always more than one way to answer these questions. Dominic. Dominic, number 4. How do you know? With? Okay, you can't just say vertical. Vertical is awesome, but vertical with what? As soon as you say 1, then I know why. Capo? Well, capo, I don't know.
Yo, I actually like that name though.
It's like her name right there. I'm never going to get it right. We already got 5, so give me 6.
6 and 1.
How do you know?
Because it's vertical.
Wait, what?
7?
That's a 7, but we don't have 7, so you can't tell me it's vertical with 7 because we know what 7 is. 2 and 6 are the same. You're right. What do we call that? Corresponding. You can say 2 is corresponding to 6 as we have 2, or you can say 5 and 6 are a linear pair because we already had 5. So, Gabrielle? 7. Why? And how are they related? How is 5 related to 7? Starts with an L. Linear pair. Linear pair. Linear pair, you could say 3 and 7 are corresponding. You could say 6 and 7 are vertical. Andrea?
Yes.
8.
Okay,
How do you know?
because the line of M is 80 degrees, 180 degrees, and 2 20 degrees. Not 20, 60.
That's not 2, that's a 7.
It's a 7.
4, I was a 2 at first.
I swear you guys knew your numbers, but I was wrong.
There we go. There we go. Now that's a 7.
So what do we call those two? Starts with an L. She just said it 2 seconds ago when you weren't listening. Linear.
Linear pair.
Linear pair. All right. Now I'm going to ask you for an angle pair. Okay? Listen to what I'm asking for. In this picture, Silas, in this picture, angle 1, 2, 3, 4, 5, 6, 7, or 8. You're telling me 2 angles. What 2 angles in that picture are alternate interior angles? Alternate interior. Alternate. Alternate. What is it? I can't hear him. 4 and 5. Good. What's another one?
3 and 6.
Good. Now, 4 and 5. What did we say 4 was?
120.
What did we say 5 was?
120.
So what can you tell me alternate interior angles are? They're equal. They're equal. Amber? Alternate exterior.
1 and 8.
Or? So what did we say 2 was? What did we say 7 was? So what can you tell me about alternate exterior angles? They're equal. Alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles that we already told you about are congruent. Dora? Same side interior.
4 and 6 and 3 and 5.
What did we say 4 was?
120.
What did we say 6 was?
60.
What can you tell me about same side interior angles?
They're not equal.
They are? So far, all day we said that they were either this or that. You said they're not equal, so that means they have to be? Starts with an S.
Supplementary.
There you go. Guys, we only had two numbers on this entire page, 60 and 120. So you were either equal or supplementary. So now that's it. Here's your 6 angles. You have vertical, linear pair, alternate interior, alternate exterior, same side interior, and corresponding angles. 4 of them are congruent. Vertical, alternate interior, alternate exterior, and corresponding are congruent. Linear pair and same side interior are supplementary. Here goes. Algebra, directions, solve for x. Here's your equation. Geometry, directions, solve for x. Here's your picture. Your equation comes from the picture. From the picture, you have to recognize the location. The location tells you which angle pair you have. The angle pair tells you what's happening. What's happening tells you how to set up your equation. So if I gave you angle 3 and angle 6, what angle pair is that? Alternate interior. Alternate interior angles are what? Equal. So I don't care what they give you for 3 and 6. This might be x plus 2. This might be 3x minus 7. Alternate interior angles are congruent, so you set them equal to each other and then solve for the variable. The picture tells you the vocab word to choose from. The vocab word tells you what's going on. The what's going on sets up your equation. Then you just solve from there. Question?
Can we see the points before you go? Our points.
Can you see what?
The points.
What point?
Don't you put the points in how we do it, right?
I got like 3.
This is a foldable. Give me a second and I'll show you what this is supposed to look like in your notebook. On page 12, you all had Miss Baker last year, so you all know what these are supposed to look like.
I ain't have her.
Well, now you know what these are supposed to look like because I just showed you.
I don't know who Miss Baker is.
Then just go home and set
Why do you want to do this together?
Thank you for such a smooth and wonderful opening to our
Here's your thing.
Are you kidding me?
Come out and dance.
I can't.
As I said, I wanted to welcome you all and thank you for a great 2 weeks.
I do have a bunch of eyes.
You call it.
Yes. Make sure my chairs go up.
I knew you were going to I'm going to get that first.
You really did. Today's Friday. I'm trying to go get my phone fixed. I'm so happy. I'm gonna get it fixed this weekend, and I'm so happy. Like, I'm going to.